At the end of the previous video, we had discussed the end behavior of the graph of a polynomial function. It either rises left or falls left, and it also either rises right or falls right. Well, there's a nice little test that can tell you exactly the end behavior of a polynomial before you graph it. It's called the leading coefficient test, or LCT. So here's our polynomial. F of x is a(n) to the xn plus ... all the way down to a0. We have two cases. If n is even, okay, remember, so n is the degree of the polynomial. an is the leading coefficient. It's this guy right here. So if n, the exponent of the x, of the biggest exponent of the x, the degree of the polynomial, is even, then we've got two cases. If it's positive, then the graph is going to do what? Is it going to rise left or fall right? Is it going to rise left or left? Or is it going to rise right and fall right? We have two choices. It's either rise or fall, rise or fall. And here's an example. It's the same for every polynomial where n is even and the leading coefficient is positive. So here's a case, a very simple case, where an is a 1. It's positive, and n is 2. It's even. Okay, so this, and we know what this looks like, something like this. So what does this one do? It rises left and it rises right. So the graph will rise right, or I'll say rises left and rises right, both directions. And actually not both directions. In the left and right, it goes the same direction. It rises. Okay, if an is a negative number, but again, it's still even, so this exponent is even, we put a -1 in as the coefficient. Well, this graph is just flipped upside down, like that. So it falls left and it falls right. All right, that's the even case. Now let's go to n being odd. All right, so the degree of the polynomial is now odd. And if an, the leading coefficient, is positive, then the graph does what left and right? Well, let's do an example. An is 1, so it's positive. And n, the degree of this polynomial, is 3, which is odd. And it looks something like this. That's the graph of f of x equals x cubed. Looks something like that. And we can see that it falls to the left and rises to the right. Falls left and rises right. All right, so the next one, the leading coefficient is negative. It's less than 0. And again, we're within odd. So here's a nice example. an, the leading coefficient, would simply be -1, and the degree of the polynomial n is 3. So it would be like this one flipped upside down. There, so we can see that it's rising left and falling right. So it rises left and falls right. All right, so this is a very handy theorem about the leading coefficient that tells you what the end behavior of a polynomial. It can help you when you are graphing a polynomial. And not a summary, but just a fact that can be stated. If n is even, this case or this case, then we have, I will say, the end behavior, it either we have rises left, rises right, or falls left, falls right. So I'll say either both fall or both rise. And by both, I mean right and left. So either the right and left both fall or they both rise. If n is odd, then notice what we have. Then one of them, one rises, one falls. It's either falling left and rising right, or rising right and falling left. I hope I got that. One is left, one is right. One falls, one rises. So the last couple of examples are very simple. We're not going to graph anything here. All we want to do is discuss the end behavior of two polynomial functions. Here's the first one. Use the leading coefficient test to discuss the end behavior. All we have to look at is this term. This polynomial has the same end behavior as does this polynomial. All you care about for the end behavior is looking at this leading term, the leading coefficient and the degree of the polynomial. So what do we have? We've got the leading coefficient is positive because it's 1, and n is equal to 4. So it's even. So if it's even and it's a positive here, we can, if we want, we can go back up to the chart here, or our examples. N is even, an is positive, it rises left and it falls, it rises left and it rises right. Okay? Now this last example, I frequently make a mistake when I'm reviewing this one. What is the leading coefficient and what is the degree of the polynomial? Well, notice this is not written in the standard form where it's descending powers of the exponent. The first thing I would want to do is really write this in the correct fashion. Actually, I didn't need to do that. All I needed to do was note that this is considered the leading coefficient, the leading term. -5 is the leading coefficient, and 3 is the degree of the polynomial. So all we need to do is base everything on the leading coefficient test based on this term right here. Where it's negative, the leading coefficient, and the degree of the polynomial is 3, which is odd. So if we wanted to, we could come back. I think it's the very bottom one. This is the case where the leading coefficient is negative, and let's see, n is odd. So it's going to look just like this. It's going to rise left and fall right. Rises left and falls right. So once again, that leading coefficient test can make your graphing of polynomials much easier. And we will see that when we do begin to graph these polynomials.